using hierarchical clustering algorithms to identify the communities. We generally consider three types of hierarchical agglomerative clustering algorithms. First is single link. Second is complete link, and third is average link. But before going towards these hierarchical clustering algorithms, we will first show how such hierarchical clustering algorithms works. All hierarchical clustering algorithms considers every node as a starting single clusters. And at the next step, it uses some similarity criteria to merge those clusters, and it continues until we get a single cluster. But the use of similarity criteria and the process we apply to merge the clusters makes the difference. So in all three categories, the way we use the similarity criteria and the process we apply to merge those clusters, initial clusters, into a larger one, plays very important role. For example, in single link, we use the maximum similarity. In complete link, we use the minimum similarity, and in average link, we use the average similarity. Now first we start with a general overview of agglomerative hierarchical clustering algorithms with a simple graph. Suppose we have a graph like this. Then first of all, we will calculate now we take a simple one to easily demonstrate this. We will use this matrix. Now by using this matrix, initially we consider every node of this graph as a cluster. Now we will calculate the minimum distance or distance between every two nodes. For example, every two adjacent node. For example, between 1 and 2, we will calculate between 1 and 4, 4 and 3. For 2, it will be 2 to 3 and 2 to 4. Similarly, for 3, it will be and like this. Now after getting this matrix, we will find at first step now at second step, identify the least distance between any two nodes. For example, suppose this contains the minimum distance. Suppose this contains the minimum distance 1 and 2. Then we will merge both clusters, and after merging, delete both columns and both rows, and merge both points, and after that delete both rows and both columns, and after that recalculate the distance. Suppose here we merged 1 and 2, so recalculate the distance from 1 to 3, 4 and like this. Suppose the merging, we merge node 1 and node 2. Then we will recalculate, and after merging it represented as, so we will recalculate the distances by taking as single cluster, as a new single cluster. We will repeat this process, and after recalculating, we will add a new row and column for n. Until we get a single largest cluster, or until we make some threshold criteria. What is the minimum meaning of threshold criteria here? Suppose we have a threshold like 40%, or in 0 to 1 form 0.40. Then it means we want to see 40% similarities among the set of points in our community. So the last step will be repeat the process until we get single largest cluster or achieve some threshold. In general case, such algorithms takes ONQ time complexity, but by use of suitable data structure, we can reduce its time complexity to ON square, where n is the number of vertex in the graph. Now I will discuss about single link, complex link, complete link and average link hierarchical clustering algorithms. For example, single link clustering algorithm. In such type of clustering algorithms, maximum similarity between pairs can be defined as similarity. Suppose pair first cluster Ci and second is Cj, then the similarity can be defined as maximum similarity. X is a member of Ci, Y is a member of Cj, then maximum similarity X and Y. Here similarity score can be calculated by using Euclidean distance or some cosine similarities or some similarities measures, like suppose in the case of documents graph or any other protein structure graph, in which the similarity depends upon the number of matchings or some kind of things, then we can use some other similarity measures like Jaccard correlation coefficient, Bayes similarity or cosine similarity. But the problem with single link clustering algorithm is such algorithms suffers from chaining effect. Chaining effect means, suppose A is similar to B or shows maximum similarity with B, and B shows maximum similarity with C, then according to chaining effect it will behave like this. It will clear from this picture. Suppose we have points like this, then at a first pass initial merging, this is the our initial merging, initial pairing. After that, the chaining, due to chaining effect, it will make like and as a final cluster, it will merge all the points. So this is if we use the single link cluster, a single link algorithms, hierarchical clustering algorithm, then we will suffer such kind of problems of chaining effect. Now, after the first step of merging, suppose we merge the point, 2 points. Suppose this is a P1 and P2. Now, we can suppose we have a point Ci. Suppose we have a cluster Ci and Cj, and after merging Ci and Cj, we have a cluster containing Ci and Cj. Now, how to calculate the similarity with another clusters known as Ck? For this, we will calculate the similarity like maximum similarity by using pairs Ci and Ck and Cj and Ck. But due to chaining effects, the entire system suffers a lot. So now I will discuss about complete link. Complete link hierarchical agglomerative clustering algorithms. Such types of clustering algorithms uses minimum similarity between pair of clusters. For example, if we have a pair of clusters like Ci and Cj, then it will calculate, then the similarity between Ci and Cj can be calculated as minimum similarity. Suppose X is a member of Ci is a member of X is a member of Ci and Y is a member of Cj, then it also suffers a problem like suppose we have a points, again we have a points like then at initial stage it will merge like this. At next stage it will merge both points, maybe slightly more distant than this, and as a final merging it will merge the whole system. So it gives slightly robust and spherical kind of clusters. But it is very sensitive to outliers. For example, suppose a point exists here, then due to minimum similarity it will shift the cluster there, and our cluster, our resultant cluster will contain the noisy point also. So it is slightly good, but not very effective for every applications. Now another step, after merging two cluster pairs, suppose we want to merge another cluster pair CK in this set, then how I will go. Now calculating similarity of cluster CK with CI and CJ. This may occur at a next step when we merge some pairs like that, and we want to merge. We were just checking whether it is suitable combination for merging or not, and if it is suitable combination, then we will merge. But to check, suppose this is a CI, this is CJ, and this is CK, then how we will check? For this we use the similarity like this. Now we will go through the average link clustering algorithms. The more sophisticated form of average link clustering algorithm is group average agglomerative clustering algorithm. In group average agglomerative clustering algorithm, suppose we have a cluster Ci and we have a cluster Cj. It contains some points like this. Then our group average agglomerative clustering algorithm computes the similarity among themselves and outside group also. Like this. And then calculates the average similarity and then merge. So it is more effective than single link and complete link clustering algorithms. So group average agglomerative clustering algorithm, the similarity criteria can be defined as it uses average similarity across all pairs within the merged cluster to measure the similarity of two clusters. The similarity criteria can be defined as Ci, Cj is equal to 1 divided by Ci union Cj minus 1 is a member of Ci union Cj and Y is a member of Ci and Cj such that Y not equal to X, then we calculate the similarity between X and Y. Now we will go through some general algorithm how to calculate the group average agglomerative clustering algorithm. We will give a naive algorithm to calculate ओके क्या बहुत ज़्यादा